We actually have one.
Okay, I think we'll start the panel discussion. So I think we had a nice day today with around logic, ontology, and things like that. We spoke also a lot about LLM. In fact, maybe for all speakers, maybe I had a general question: is that when you're using LLM to generate formal expression like logical expression, so you both did that, and so maybe you can understand, you can answer this question, but with machine learning, you often have the fact that it can give good result, but sometimes the reason for the good result can be some sort of surprising. You have that with image recognition, where you have like you had result like it detects properly that this is a picture of a fox. But when you study to try to see which pixel in the image or the important one that make the decision trigger to fox, then it's the white spots, because the white spots are the snow in the picture. And it's because finally it correlates fox is a picture with some dots of snow. So it can work really well, but sometimes the reason can be like surprising. But when you're generating formal expression like logical expression, and so you can have the same thing that could happen, that maybe it's because some characters or some punctuation character or something in the syntax, and that just triggered like I don't know what you think about that in your own work on the impact that something like that could have, that maybe it triggers the right answer, but maybe for some sort of really minor decision. I don't know. Maybe you can start with Ian. So you.
Okay, so I take the question to be generally about data artifacts, right? So it may well be that a machine learning program, neural network, let's just say neural network, gives pretty good answers on some test set, but for the wrong reasons, right? And this was, I mean, this is a phenomenon we all know about. And it's certainly something that arose in one of the strands of using LLMs to do natural language reasoning that I briefly mentioned in my talk. In particular, this work in which you have large human curated data sets where you have premises and hypotheses, and the machine is required to determine whether a hypothesis, as they call it, really follows from a premise, so on and so forth. And there have been some really evil experiments done on these sorts of results. So, for example, there was one study where a data set was taken where a language model was shown to perform extremely well in determining whether a particular inference is valid. So the inferences, so you've got a lot of premise hypothesis pairs. LLM does really well. And so what the challenge experiment said was, well, okay, we'll take the premises and we'll just replace them with asterisks. Okay, so we'll just blank out the premises and let's see how well the language model does now. And okay, surprisingly, it does really well. And the reason it does really well is because, well, the conclusions have conclusions which tend to follow have fewer negations in, and then they have lots of existential quantifiers, and if they have lots of universal, so you can see really quite incidental features of the data set can be used to guide language models. And of course, this is a known phenomenon. How do you get around it? I mean, so yes, yeah, we get this all the time. And it's not just, so Roger, you asked the question in connection with the problem of translating natural into formal languages, but it arises quite generally, where you're asking any machine learning problem to, so you get data artifacts.
Yeah, but even verification, when they check that some argument is correct, it could like some sort of be triggered by some keyword or something like that.
Absolutely. And how do you get around that? In the experiments that we did, what we tried to do is we were aware of the fact that most logic problems are trivial, right? Actually, if you generate a random problem in logic, it's usually trivial. So if, for example, when you generate a problem, there are very few negations, probably that set of sentences is going to be satisfiable. If there are very few statements compared with the number of free variables, the number of terms, very likely that the problem is going to be satisfiable. This is known from satisfiability testing, where you have a phase transition phenomenon in which if the number of constraints is very large compared with the number of propositional variables, you get very low probability of satisfiability. Very low probability of satisfiability. If you get very few constraints compared with the number of propositional variables, high probability of satisfiability, and a neural network will just learn that. I mean, the machine will just learn these rather trivial facts. Now, to some extent, you can say, well, if the data artifact's general enough, well, that works. That's okay. That's a good guide. But of course, it's not really doing logic, and so the way to get around that is to when we were doing our experiments, we focused specifically on the hard areas of the problem space. So we did initial experiments to find the hard areas of the problem space, the challenging regions of the problem space, and we trained the networks on that and tested them on that. And so that's the only way I'm aware of getting around the problem of data artifacts. You need to look at the hard areas of the problem space if you can parameterize problem space.
So in fact, when you're testing a condition, so you want to know is it satisfiable or not, it's a yes, no question. So clearly with some general knowledge about the size and you already know the answer. But in the case of Lean, then you're generating expressions in some sort of way. The search space is much bigger. But do you think this kind of phenomenon also can happen, that it triggered from some minor aspect, it trigger a query which is almost correct or something like that?
So I think I showed in my talk, we actually do get hallucinations, which is sort of a generalization of this phenomenon. But that's really why in my architecture, the fact that that last step is deterministic is really important, because that last step is checking the syntactic and to some extent semantic validity of the query without appealing to any machine learning or LLM or anything at all. That's a pure graph-to-graph comparison, and that was not accidental, and the significance of that was not lost on us when we did that. It's like if our last step is deterministic, we could say, oh, here's a mistake, and we could take an LLM back again. We could cycle there. That's very expensive. We try not to do that. Yeah. In principle, you can, but the last step has to be the deterministic one. If your last step is the LLM, then you're just walking right into the issue that you're talking about. And the folks who are doing, they're making all the advances in mathematics nowadays. Their last step is one of the big theorem provers at the end. The LLM produces a theorem, yeah, whatever, that's worthless. The theorem that has gone through that theorem prover to be validated, now that validation doesn't come from the LLM. And there's actually a saying that occasionally you find in philosophy: the validity of the argument is independent of the source. That's basically a non-ad hominem. So the LLM comes up with something that who knows what it's drawing it on. If you verify that it's true independently and not through an LLM, through a trusted source, a theorem prover in the case of modern mathematics, or just the graph comparison in my case, then you've got an independent validation. And that scenario doesn't make sense in where Ian is, because he's trying to get or I think maybe what Uli has to say about this, where you're actually trying to have the LLM gain new competencies. I'm sitting in an engineering setting. Remember, I stopped doing science about halfway through my talk, and then we're doing engineering. I want something that works, and that can be validated in an independent way.
No, okay. And in your case, you're trying to learn embedding, so it's also machine learning that it's trying to learn this embedding. But can you get this same sort of phenomenon that you will get quite a good embedding for the measure that you're using, but it's triggered on from some sort of minor aspect? Can that happen?
So I'd like to move away from the embeddings because we're talking about something else entirely here, basically.
Okay.
Why are LLMs so good at out, basically, or at logic? And the reason, I mean, Dean explained it very, very nicely. There's a lot of documentation out there. It's a super simple language compared with English. There's some special keywords in there, and the constructors are all quite simple. And it's for a modern LLM on neural network. It's quite easy to learn how such a small language, and it has done, or Sparkle. So I remember, I think that 4 years ago or so, Pavel Klinov, a friend from Stardog, was saying, "Oh bloody hell! For years we tried to teach so Stardog is a company, a European, an international company working around our tools and consultancy. And they tried to explain to their customers for years how to write Sparkle queries, and they never got anywhere. But now with LLMs, just work like a treat.
Yeah. Here. For years, I've been saying, Sparkle is easier than SQL. You saw my slides for that. And I've been like, no, I know SQL and I cannot figure out Sparkle. It's like, no, read Kemp's book from the 70s. You have been caught in the hegemony of tables and you were trained to think in tables and you think that's the only way. Little kids think in graphs. The teaching RDF to a 6-year-old, fabulous blog that Ian Dodds, I think, wrote many years ago. And actually, Aura Lassa tells the same story. Kids get graphs like that. Once you've been taught tables, you forget everything you knew about graphs. But I've made the same comments as our friends at Stardog have said. It's like, you know what? I don't have to convince Ashley Faith that Sparkle is easier. I don't have to convince the director of data at Bank of America that it's easier. I convince one person, and that person is writing everybody's queries anyway, and his name is Claude, and Claude knows it. Claude knows it's 3 times easier, and I've got the receipts. And you know what? I don't care if you don't believe me, Ashley. I don't care if you don't believe me, CDO. It's true, and Claude knows it, and Claude's writing all your queries anyway.
And these models are very good at looking at the given ontology and understanding the labels used there. So the special terms or the terminology.
And just to add to that, this is my governance point. Thank you for that, Uli, because you're going right down to governance. Let's suppose you didn't give it a good enough label or a good enough comment, and it doesn't do what you want. You can now go and say, oh, you know what? No wonder that label is silly, or that comment is silly. And now I know why, because it misled Claude, who's awful smart. I'm going to stop misleading Claude. I'm going to write a different comment there. And that is how our governance typically works. This governance now feels an awful lot more like the way you govern employees, human beings. Oh, I just needed to tell you, we don't, when we say account, we don't actually mean what you just did there. Yeah, next time you'll get it better, and next time a human being does, and next time Claude does. So it's governable in exactly the way that Uli was talking about.
Yes, but at some point, I'm sorry, maybe somebody else wants to come in. There's something I don't quite understand. I think the sense of the question was that, okay, so we're not using, and the sort of things you were talking about in your talk, we're not using neural networks to language models to answer the question, using them first to do a translation. Then you really ask the question. But then the problem is the translation correct, right? And I think the worry that Roger was well, maybe the kinds of questions that it often gets asked will allow it to use certain shortcuts. I mean, it will be used just on complexity theoretic grounds. We know it must be using shortcuts because it's a constant depth network. So come on, look, and then there are going to be things there where we know it will make mistakes. You won't be able to catch them, right? And yeah, I think that's the.
Yeah, I make mistakes too.
Yeah.
There's that, of course. But that's, I feel like you're just walking into my talk here. Why do I have that initial phase while the user is still there and can be interrogated? And when you get to the end of that, you now have a question that is quite unnatural, but so specific. Now, will you get this down to 0? No. But you know what? You don't get down to 0 with a meat machine either. So that down to 0 is not a realistic thing anyway. And that's why I feel like you're just walking right into my thesis. That's why I have the 3 phases. That first phase is to do your best at dealing with this. That last phase is that deterministic one to make sure that you did your best at this. And then the one at the middle, in some sense, is almost that's the easy part.
Any question or somebody from the public who want to ask something to the panelists? Yeah.
Julia?
Oh, there's some up here, yeah.
Ah. I would like to see chain of postile reasoning.
You enjoy this?
Also saying that to an expert style, it's a kind of intelligence.
That makes it, here we go.
Practical text.
Yeah.
Any transformers trained with threat?
Yeah.
So, it says for the panelists, this seems to be directed to my talk. So, that's. I'm not going to show a chain of thought style reasoning, but this mixture of expert style architecture work with an LLM and some kind of an ontology symbolic system. I've not actually, in principle, you could do that. I've not found a whole lot of need to do that. We actually did build, when we started to productize this a couple of years ago, and a agentic system that did this. I've actually found, so far anyway, that a non-chain of thought thing, basically good old-fashioned waterfall. My diagram was a waterfall diagram, right? And unapologetically so. A train of thought would be a lot more, well, an agentic one would be a lot more agentic. And I've not actually found that necessary. And one of the problems with that, I think, is you're getting at in your follow-up. If you were to do it agentic, you sort of lose control of the cost. We talked about that briefly during my talk, that you keep bringing an LLM in over and over again. Now, the ontology is a very cheap agent. It's a query engine. And actually, now I'm thinking about this, one of the things that we have done is to put an agent as a Sparkle endpoint over top of the ontology, so that, this is my building ontology scenario I talked about at the very end, so that if the main agent wants to know anything about the ontology, you can actually write Sparkle queries. You know what Claude does on its own if you don't tell it? It does regular expressions over turtle. That's not very high fidelity. So we've given it a Sparkle endpoint. But I think that there's a lot of possibility in the direction that this question is going. We haven't done a lot of it because we haven't had a lot of need for it. So that's kind of, we're being need driven here.
But the interior process question, it could be brought back to an ontology. If you have some sort of ontology or describing this interior process, you could
Okay, I think
you could generate expression, but around this kind of conceptualization, that could be possible too.
I'm not sure I understand that.
I was linking to the interior process question compared to plausible sounding reasoning. Is that you have this formal expression which is a constraint and something like that. Okay, it's some sort of reasoning or referred to reasoning. But the interior process structure could also be defined by some ontology, and then you could produce an artifact in relationship with that, which would be also an explanation, but maybe not a reasoning expression, but an expression on some sort of, I don't know what's meant here, but the interior process is some sort of cognitive architecture or linking things. It could be possible too.
Okay, yeah, that's beyond what I had thought about for here, but basically you're thinking of the ontology orchestrating the agents
Yeah.
as well as being a resource for them to use. And I have not actually given that any thought at all. So I don't have a whole lot to say about it. And I sort of like we're going a bit too deeply into my talk. We should get some more general things to give the panelists in.
We could ask Julia to explain her first question. So because I am now unsure
Yeah.
what she is aiming at. So what kind of chain of thought style reasoning for what query? What's the question she wants to know the answer for?
Yeah.
So Julia, could you explain what you mean?
Yeah. Can we give Julia a microphone?
I'm sure we could. We just need to also make her a panelist. And then
Yeah, there you go.
You could speak also, you can
There she is. Method apartheid. Okay, there we go. We're gonna do it for everybody.
Hello.
okay.
Go ahead. Okay, cool. Yeah, thanks. Sorry, I didn't mean to cause logistical hassle, but basically, yeah, I was wondering, one of the big issues that I'm curious about is that, like, even when you're interpreting like some performance metrics or something with an LLM, because often the plausibility of the answer is actually correlated with giving a right answer, then that makes interpreting sort of what's going on under the hood much more difficult. And like you guys had mentioned, like, how do you know what pixel the model is relying on? And if that's maybe sort of something totally orthogonal to what you actually want the model to be relying on. So I was thinking in line with that, if now that there's all these, I mean, there's so many architectural choices, it gets a little overwhelming to consider like what all the ways you could set up a model are. And there's a lot of mixture of experts that sort of tries to modulate the primacy of that initial plausible text generation objective by adding additional objectives during training on top of that. And this ontology approach seems like, or like other approaches where you combine a symbolic approach and the neural approach, seems sort of in line with that to me, in that you're sort of building a fundamental language competency with the plausible text generation, but then you're trying to modulate that with additional training or additional strategies that are accessible to the model. So I was wondering, out of all the ways you could imagine sort of incorporating ontologies, like, could a model be sort of like a mixture of expert style model intertwined deep learning, but also like a more symbolic approach or an ontological approach that helps, that basically gives you another strategy besides plausibility as the guiding star? Sorry, that was like too long and confusing.
I think if I may, to translate your view and Dean's approach into something perhaps somewhere in between. So in my understanding, Dean suggests to have an LLM build an ontology-based data integration system, because we have the data in some company, there's data in some databases somewhere. It's fixed there. We want to have easy access to all of them. We don't want to build it ourselves. We know that we could build it with the help of ontologies, but it would be very cumbersome. We would need to build ontologies and all the mappings from the data sources and so on. Basically, Claude does it for us with a bit of guidance. Is that, but then the kind of reasoning and what you need is basically already inherent in the ontology and the overall ontology-based data integration approach. Does that make sense?
Yeah, to be honest, I'm not entirely sure. I it was a kind of open-ended question with many directions to it. So I thought all three answers I've gotten have been really interesting and helpful. So I appreciate it, guys.
Well, could of course combine end-to-end machine learning with the kind of approach. Sure, and there's no reason why you shouldn't do that. That's a sanity check. Yeah.
I think one of the things that happens to me every time I answer a question is I throw it into this very familiar paradigm of question answering. You know, question comes in, and well, my innovation, such as it is to do this translation thing. But there's so many more things you want to do with knowledge and data than answering questions. Just in answering questions when we can get our heads around really easily. And I feel like almost every time I answer, I'm kind of limiting the discussion because I've got this nice architecture, it does what it's supposed to do. But it's solving a problem that is by no means general, right? Answering questions about data is one of the things you want to do. But finding satisfiability of things or learning how your graphs can extend. These are completely different kinds of questions. And yeah, they're actually harder to get your head around because it's not like, gee, I've got a whole bunch of graph data and I know what extensions I want to have with it. And yeah, that happens to me every day. Whereas wanting to ask databases questions is something that happens every day. So I almost feel like I'm unfairly dominating this conversation, and we really should be thinking laterally. And I think that's what Julia is basically asking us to do.
Can I respond to the question by answering a kind of opposite question?
Yeah.
Which is a mean kind of a mean sort of strategy, isn't it? A lot of the things that the other speakers generally, actually, I mean, everyone apart from me, were looking at was really, so the idea was, well, we're going to use language models to do some interesting translations. Things with them. What can language models do? But you were looking at, this is really a question to everyone, all the speakers. You were essentially, I think, using zero-shot inference, right? So you're saying to Claude, here we are, Claude, here's a thing, translate that. Have you thought about fine-tuning? That is, you must have some examples of translations that are good. Have you thought about fine-tuning these?
But and now we're getting back into this architecture of question answering. Actually, the architecture I showed isn't necessarily one shot because when you get that, if that third deterministic thing says it's a problem, the easiest thing, the first prototype I did was say, just throw it back to Claude and have it do it again. That was the easiest thing to program. It's hard, by no means the cheapest because you're basically using the LLM at full power every time around and you have an indeterminate number of groups there. But another thing that, and actually I should mention, Uli mentioned our friends over at Stardog. I saw our friends at Stardog at a conference at the KGC about a month ago, almost exactly to the day. And guess what? They're doing exactly the same architecture I described. As far as I can tell, they didn't have that third step. At least they didn't mention it. But hey, it's a big architecture. I actually they had a little tutorial where you could walk through their system and basically it was all the same steps. And that one of the things that they do and that we've talked about doing, but they're ahead of us, is that they do something very like that. If you have a question that comes up a lot, they remember the question, remember the query, and then another round of governance. A human being comes in and says, that query is, in fact, in my opinion, as the chief data officer, is the correct query for that question. And you get a nice little CDO stamp of approval. And now you've got another machine learning round. When a question comes in, can you figure out of the certified questions, is this one basically another wording of one of those? And now you have a whole phase that I didn't talk about at all because I don't have it, but Stardog does, where they'll actually look up the questions, and that lookup needs to be a smart lookup. And so there you get another round of that. And that, of course, can be tuned and governed. So my general statement still applies here. You can govern this stuff, but they're governing at a different level. And I think it's probably a lot of opportunities for that. And I think that might be what Julia was getting at.
But okay. Yes.
Can I ask a question to Dean? So I recently saw a very interesting talk by Karen Howe. So in her language, you're using a space rocket for a bicycle.
Yeah.
A trip. So you use Claude that can do all sorts of stuff, and you use a tiny little bit of Claude's brain to build ELT systems. In some sense, could you? Now, when would it make sense to build that bicycle properly to use in different companies, or perhaps is this what Stardock is doing?
Yeah, so they are. So the bit in the middle, that translation bit, I don't think we're using a spaceship to do where we could use a bicycle for that cycling at the end. Cycling, said I did there. I think that I in my first one, I did absolutely use a rocket ship for a bicycle. Could have done better. And for that question, look up again. I could definitely use Claude to do that, right? And say, hey, here's a bunch of questions, figure out which one's closest here, and tell me how much you like that. I think a VDB would probably be better, but you'd have to tune that VDB just so to do that. So first, I'm going to say guilty as charged. Okay, but at prototype stage, I think you're allowed to be guilty charged of that. But that one in the middle, that translation where you're reading an ontology and understanding that, I think that's actually, I don't think that you're actually underutilizing Claude for that step there. I think you actually do need all that history of having learned about OWL over the last 25 years from all those academics, things have been going on. And I know that you and I have both published here, so what I'm spitting on both you and myself. All that academic stuff, all that logical stuff, all those reasons I said that OWL was a good thing. I think there you actually do need it. And Claude's history with that is actually really good. For the rest of it, yeah, I think I am. Or the killing a fly with a sledgehammer is the other metaphor that people often use for this. And I would say guilty as charged. I think at the moment, I did the tutorial with Stardog a month ago, and they were bringing Claude in quite a lot as well. Well, an LLM. I don't know if that one was Claude, but I'm sure that their plans, because it's expensive to do that, is in fact to start economizing on that. Put a VDB where you could, or some more finely tuned machine learning system, some other technology that would be lighter weight. Because yeah, those rocket ships are expensive.
There may be something I'm concerned about. So it's sure that you have an impressive result with machine learning methods that also come from massive use of data, but I have some concern about the fact that when you have logic-based formalism, then often it's often the details that you're having problem. Is that if you look like in an ontology, there's decision that has to be taken on how you're going to structure this knowledge. But when you take some knowledge from the world, often the problem are in the detail and